we are going to study the different methods which are used to find out the average rainfall data. So let's start. So in an area when rainfall is occurring, so we need to calculate the mean rainfall, so that we can estimate the particular area, because the rainfall intensity varying is in the area. So to the evaluate the means or average rainfall in an area, we use different methods. Last one is arithmetic mean method. Now it means arithmetic mean methods. Now it means simple average method, which is used to calculate the mean rainfall, and this method is suitable when rainfall distributions is uniform throughout the area. For example, consider this is an area. We are having different rain gauge stations. That means these are the points we are measuring the readings of the rainfall. So for example, we take 4 rain gauge stations. We are assumes that the rainfall is uniform throughout this area. That means across all of these rain gauge stations, the rainfall intensity will be same, because if 4 semi of rainfall falling over P1 stations, then P2 stations also having 4 semi rainfall, and P3 and P4 also same within particular time. That means the rainfall distributions is same throughout the time. So through this method we can calculate the average rainfall in following formula. So average rainfall PM equal to P1 plus P2 plus P3 plus P4 and so on, divided by total number of stations. Means we are calculated the total rainfall value of all stations, and it's divided by number of stations. So it is the method of arithmetic, and its some drawbacks are, but this methods does not gives accurate result, because it is not possible that rainfall distributions will be uniform throughout a particular area. So that's why these methods not give you accurate result because of its assumptions. So moving on the next method, Thiesen's polygon method. Now what is this method? So in this particular method, the calculations is done based upon the weighted mean concept. Now question is, what is the weighted mean concept? So let's see, this is an area. This is, we will divide it in this area is a particular 3 part or 3 blocks or divisions. This is first, second and third. So first part, that is having a rainfall as a P1 we denote, and then second one rainfall is having P2, and third one rainfall is having P3. Now in this area, the A1 is representing the area of first one block, A2 and A3. These are the respectively the area of the second and third block. Now in this weighted mean concept, what we do, it assigns the certain weight, that means of the entire area, how much as covered by first block or part. For that the weight is calculated by the area of the particular part or block of an area divided by the entire area. So let's see, if these 3 blocks is equal, that means the area will be 1 divided by 3 and total area is A. So weighted assigns that the first blocks will be 1 divided by 3. So what we do in this case, the adjacent stations, they are connected by straight line. The stations are, in this method the stations are connected by straight line. Now let's see, we considered a triangle. This points presents in a catchment area. Now these adjacent stations are connected by the straight line. Just assume that these are the straight line. Then dividing the entire area into series of triangle. So within a area there are the three rectangle there are three rain gauge stations, P1, P2 and P3. Now in the next steps the perpendicular bisectors are drawn on this straight line. So bisectors are drawn in the straight line. So the perpendicular bisector, that means it will be perpendicular to the straight line, and both of the side which bisected by the line, that will be equal distance. Similarly the point in a equal positions for every point. So in this case what is happening, it is forming a series of polygon around each rain gauge stations. So this is a first polygon around P1 stations, then similarly around P2 and P3, and each polygon contain only one rain gauge stations. And then the average or mean rainfall calculated in proportions of the area of this triangle. The area of the triangle is proportional. This calculated the average or mean rainfall. So the formula, if the mean or average rainfall equal to P1 stations into A1 area plus P2 stations into A2 area plus P3 stations and A3 area and so on, divided by A1 plus A2 plus A3 plus AN and sum of the area. That calculations gives us mean rainfall. That is the second method. And some its drawbacks are, now in this case the assumptions that will assumes in first method that rainfall is uniform in the all stations. That is not required. In this case the rainfall is different across the rain gauge stations, but also in this method there are also a certain drawbacks, that when the shape is very complex, how we do proceed this method, this is an questions. And now we move into next method. So first of all we know what is isohyte. So in area these are the different point, which are representing that rainfall which falling in the area, that is 10 semi. So if we draw a line within points which having on equal rainfall value of 10 semi, then such lines is known as isohyte. So isohyte is a line which joining the points of equal magnitude of rainfall. Now what will be the map is representing? So a isohyte map represent the contour of equal interval isohyte line. It means if the first contour line's value is 6 semi and next contour line's value of isohyte is 8 semi, then the interval between two isohyte is 2 semi. That will be the remain constant. So that means equal rainfall interval and area enclosed between two adjacent isohyte is measured by a planimeter. Now let's see, we are having different rainfall across the isohyte. So represent that first isohyte line represent P0 rainfall, second is represent P1 rainfall, then next are is represent P2 rainfall, and the line represent P3 rainfall, and the area enclosed by a boundary which are known as catchment boundary. So let me highlight that. So the boundary is highlighted with the yellow color. So area between the boundary of P0 is A0 and area of P1 rainfall is A1, and P2 rainfall cover the area is A3, and P4 rainfall cover the area of A4. So how we could calculate the average rainfall? So between P0 and P1 rainfall we will take the average value. So that is written as P average 1 equal to P naught plus P1 divided by 2. Similarly, between P1 and P2 rainfall, we will having P average 2 equal to P1 plus P2 divided by 2. Similarly, between P2 and P3, that is P average 3 equal to P2 plus P3 divided by 2. And now to calculate the mean rainfall, this only one change, that is place of the actual rainfall of these stations, we take average rainfall. We take average rainfall with different isohyte in this method. So to calculate the mean rainfall, we will be multiplying P naught into A naught, because in this case what will happen, this is the actual area. So in that area there is only one rainfall, that is P naught. There is no other boundary. That's why this is P naught into A naught plus P average into A1, P average 2 into A2, and P average 3 into A3, so on, divided by sum of the area. So this is the represent of mean rainfall. Now the area between two adjacent isohytes, that is considered to receive the mean rainfall, represented by concerned isohyte. That means if the concerned isohyte is P naught and P1 and the area is between them, that is assumed to receives the rainfall, that is the average of these two values. This method is superior to the others two methods. That means superior to the arithmetic method and superior to the Theisen method, especially when the rain gauge stations are more. So finally, at a glance, the arithmetic mean method required rainfall distributions to be uniform. Theisen's polygon method required the different geometry that is very complex. That will be avoided so much. Now isohytes methods, we can calculate the mean to find out the average rainfall isohytes. So these are the three methods through which we can determine the rainfall average value. So thank you everyone.